Good morning, dear students. Welcome to Jatin's Academy. Today in this class, we are going to start with first chapter of class 8 ICSE chemistry, that is matter. In this class, we will complete this chapter matter. So let's get started. So before starting this chapter, as we know, the name of this chapter is matter. So we should know that what is a matter. So what is a matter? Here is a definition. Anything that occupies space and has mass is called matter. Whatever things we are watching in our surrounding, like we are watching table, chair, laptop, computer, or whatever things are there, that all things are occupying some space and all things are having some mass. So these things which are having some space, which are occupying some space, plus they are having some mass, so that materials are known as matter. Fine. But if I talk about like thoughts, if I'm talking about thoughts, I'm having good thoughts, I'm having bad thoughts, or my feelings, is that feelings or thought is a matter? No. Feelings, or you can say thoughts, or you can say like light or shadow. Okay, these all things are not matter. Why these all things are not matter? Because these all things do not occupy any space, plus these things do not has any mass. So feelings, thoughts, light, shadow, these all things are not regarded as matter. Fine. Kinetic theory of matter. In kinetic theory of matter, we will discuss about their molecular arrangement, we will discuss about their motion, how they are moving in matter, how particles are moving. Fine. So kinetic theory of matter was developed around about 200 years ago. About 200 years ago, this kinetic theory of matter was developed by the scientist. Which scientist? Dalton, Joule, David, Maxwell, Boltzmann. So these are some scientists which discovered the kinetic theory of matter. And this question, this kinetic theory of matter is very important from exam point of view also. It is having 7 to 8 points that we are going to study one by one. So first main postulates of kinetic theories are as follow. First main point we are having, every matter is made up of tiny particles called molecule. As we have learned that each and every matter is made up of tiny particles. So that tiny particles are known as atoms as well as molecules. Because two or more atoms are going to give molecule. So every matter is made up of molecules. Second, molecules of a substance are identical in shape, size and mass. If I am having one substance, if I am having here for example table, so whatever particles are there in this table, the size, shape or mass of that molecules in a substance are same. Okay, whatever particles, whatever molecules are there in this table, so that all particles are having same shape, size and mass. But if I am having two different substances, one table I am having, for example, one small table or chair I am having, these particles are having their different arrangement or different size, shape, and these particles are having their different arrangement. So, according to the substances, we are having different mass, size, shape, and composition of particles. Next, we are having third point. Molecules are continuously in a state of random motion. Whatever matter we are having, for example, we are having table, chair, water or perfume, anything we are having, each and every matter is made up of some particles, or we are having molecules. So in each and every case, these molecules are in a continuous state of random motion. So motion of molecules is different in different states of matter. See, in this case of solid, motion of the particles are different, but in liquid motion of particle is different, as well as in gas the particles are in different state of continuous motion. Fine. So these motion of the molecules is varying from matter to matter. Fine. Next we are having next point, fourth point. The motion of molecule increases with increase in temperature. As we are increasing the temperature of any substance, for example, here I am having the water in a beaker, and if I am giving temperature to this water, so firstly these molecules are having their random motion, they are moving here and there. But when I am giving more and more temperature to the water, the motion of the molecule start increasing. So due to this increase in the molecule of the motion, it means that with the increase in the heat, the motion of the molecules also increases. And same with the decrease. If we decrease the temperature, with decreasing the temperature, the motion of the molecules also decreases. Next we are having, due to molecular motion, the molecules of substance possesses kinetic energy. Whenever in any state of matter, when molecules are randomly moving here and there, what does it mean? Means the molecules are in which energy? Kinetic energy. So these molecules are having kinetic energy. Kinetic energy of the molecule increases with increase in temperature. That is same above point. Like if we are giving temperature to any state of matter, to any substance, when we are giving the heat, the kinetic theory of that molecule or kinetic energy of that molecule increases. Fine. Next we are having sixth point. The molecules of a substance have space between them. Whatever state of matter we are watching, for example, here I am having solid, here I am having liquid, and here I am having gas. So the molecules of a substance, these molecules of a substance are having some space in between it. And this space between the molecules of substance, this space is known as intermolecular space. Intermolecular space. Fine. So this intermolecular space is very much least in solid, and intermolecular space is there, means some spaces are there in liquid, and intermolecular space is least in the gases. Fine. So here it is written the same. The intermolecular space is maximum for gaseous state and minimum for the solid state. Why? Because in solid, molecules are closely packed. If two molecules are very close to each other, means here intermolecular space is minimum, and here molecules are very apart from each other. One molecule is here, one molecule is here. So here molecules are having too much space between them, means the intermolecular space is maximum. Next point we are having, molecules attract each other is called intermolecular force of attraction. If I am having any like matter, here I am having a solid. So in each and every state of matter, molecules are always attracting to each other. Molecules are always attracting each other with which force? With the intermolecular force of attraction. The force present between the molecules of the matter or molecules of a substance, that force is known as intermolecular force of attraction. And these forces of attraction are of again two types. What are these two types? Force of cohesion and second is force of adhesion. We are going to study one by one about these types also. So forces are of two types. What does it mean? See carefully. For example, here I am having a water in this glass. These water molecules, here see, water molecules are having in this beaker, water molecules are there, and in water molecules particle arrangement, for example, is like this. Okay. If the force of attraction is there between the particles of same molecules, for example, water is there, here water molecule, here also water, here also water. So if the force of attraction is there among the same molecule, this is also molecule water, this is also molecule of water, here also, if they are having same molecules of a substance, then this is known as force of cohesion. But what do you mean by force of adhesion? See carefully. In this beaker, if water is there, means water is retaining in this beaker. Water is not moving here and there. Water is not going anywhere. Why this water is not going anywhere? Because these water molecules are having some force with the glass. So these water molecules, if are having some force with the glass, that is why these molecules are not going outside. So this force of attraction between the two different substances, one water molecule is there and one glass is there. So whatever force is present between the molecule of water and this substance glass, this force of attraction between two different substances is force of adhesion. Clear? Again I will repeat for you. If in the like here water molecules are there, here all inside the beaker water molecules are there. The force between the same substances, same water molecules, this is force of cohesion. But if two different substances are there, one water is there and one glass of beaker is there, so that two like substances are having force. If the force is between the two different substances, then we are having force of adhesion. Next we are having The magnitude of intermolecular force depend upon nature of molecules of given substance. The intermolecular force also depend upon given substance. If I'm having here solid, so in solid particles are closely packed. Particles are very closely packed. If particles are very near to each other means the force of attraction between the particle is very much strong. But in the liquid, particles are far away from each other, means particles are having at some distance. So due to this distance, due to intermolecular space, intermolecular force of attraction is little bit weak as compared to solid. But if I talk about the gases, in gases spaces are very much high. The intermolecular spaces are too high in the gases. Due to this more intermolecular space, force of attraction between the particle is very much least. Fine. If particles are very close to each other, very close means force of attraction is very much close. If like in liquids, particles are away from each other, intermolecular force of attraction is little bit least. But if particles are very away from each other, then force of attraction is also very least. Fine. Next we are having next topic, molecular arrangement in matter, that is 3 states of matter. Now we are going to study that how molecules are arranged in all 3 states of matter, that is solid, liquid and gases. So first we are having in solids. Molecules in solids are closely packed. As we know that in molecules, particles are very arranged very close to each other. If they are having very close arrangement, then intermolecular space is extremely small because particles are very close to each other. So no intermolecular space is there. Here intermolecular space is very least in the solids. Second point we are having, intermolecular force are very strong. As we have learned that particles or the molecules in a solid are very closely packed. If they are very closely packed means no intermolecular space is there. It means that two molecules are having very strong intermolecular force of attraction. If in solid intermolecular force of attraction is very strong, it means solids are having definite shape and definite volume. Here for example, this I am having a table. So you can see that particles are very close to each other, means particles are having too much force of attraction. If particles are having too much force of attraction means they are having definite shape. We cannot change the shape of table. Plus they are having definite volume also, means the space occupied by this volume is also definite, is also same. Clear? Next, third point we are having, in solids, molecules can have only vibrational motion. Means here molecules are only vibrating about their mean position. Like this they are vibrating, or like this they are vibrating. They are not moving here and there. Like this they are not moving. They are just vibrating about their mean position. And if the molecules are vibrating only about their mean position, then that motion we call it as vibrational motion. Next we are having, a solid cannot be compressed on account of close packing of molecules. As we have learned, in solids, molecules are very closely packed to each other. If particles are very closely packed, for example, this table I am having, if particles are very closely packed, so can you compress this table by applying some force? Can you compress the table and can you change the shape and size of table? No, obviously no, because in particles, no intermolecular space is there, or force of attraction is very much high. If force of attraction is very much high means solids are hard and rigid, so we cannot compress solids at all. Okay. Next we are having, a solid cannot flow. This is obvious that if particles arrangement is very close to each other or the force of attraction is very much high, so solids cannot flow, or your table is flowing here and there, or your table is moving alone here and there. No. Wherever solids are kept, they are going to kept there only. They are not going to flow anywhere. Okay. Plus it can be stored independently without a vessel. If you are having table in your home, or if you are having book in your home, you need any container to contain that table, or need to container to contain that book? No, we need not of any container to contain the solids, because solids are not going to move anywhere. So don't worry, no need of container to store a solid. Next we are having liquid. So here we are going to study about the molecular arrangement in liquids, that how molecules are arranged in liquids. The molecules in liquids are less tightly packed. As we have already learned that in molecules, some intermolecular spaces are there between the particles of liquid. If some intermolecular spaces are there, means force of attraction is little bit less in liquids, and intermolecular space is also somewhat more as compared to solid. Next point we are having, if somewhat force is there between the liquid molecules, so it is having less intermolecular force of attraction between the particles. Hence, a position of molecules is not fixed. If there is no intermolecular force of attraction between the particles, so particles are free to move here and there. I will give you one example here. For example, in a class, here your teacher is standing, and here you are sitting, and here your friend is sitting. If you are sitting very close to your teacher, means intermolecular or the force of attraction between the teacher and you is very much high. If intermolecular force or the force is very high between you and your teacher, so you cannot leave the class very easily. But the student which is sitting very far from your teacher, here space or the force between the teacher and student is less, so this student can move freely here and there because it is not under the guidance of teacher, you can say. Same way in a case of liquid, here liquid are having some space between the molecules. If some space is there, so force of attraction is less, so liquids can move freely. Okay, here also you can see the liquids are moving freely. Does liquid have no shape? Liquid is also having not proper shape. Why? Because particles are not that much close to each other, or force of attraction is not that much high. If force of attraction between the molecules is not high, so it is not having its proper shape. So they can also flow easily due to less force of attraction. Next we are having third point, the molecular force do not allow the molecules to leave the liquid easily. If I am talking that the two liquid particles are having some space between them, or they are having less intermolecular force, it doesn't mean that molecule now will move from one place to another or it move from the beaker. No, somewhat force is there. Here also somewhat force is there that do not allow the liquid to move out of the glass. Okay. So here some intermolecular force is there which do not allow the liquid to move out easily. So a liquid has definite volume. Due to this force of attraction, the liquids are also having some definite volume. Volume means if here 100 ml of water is there, if I pour this water into different shaped container, here also it will take 100 ml only. Fine, here also it will take 100 ml. It doesn't mean if here 100 ml is their volume, here it will convert to 500 ml. No, volume of the liquid is going to same only. Fine. Although it does not have definite shape, but yes, if I am having beaker like this and here I am having beaker like this, or like this beaker I am having, shape is going to change. When I am going to pour into it, shape is going to change, no problem, but volume of the liquid is going to same. Next we are having a liquid can compress only a little. If particles are little bit away from each other, we know somewhat little bit force of attraction is also less, but here some force of attraction is so there, no? Some force of attraction is there, so due to that force of attraction we cannot compress the liquids that much. Liquids are only going to compress a little. Fine. Fifth point we are having, a liquid can be stored in a container. So whenever we want to store a liquid, in order to store a liquid, we need some kind of container. And a liquid has a definite and only one free surface. What do you mean by this free surface? See carefully. Here, for example, in this glass, water is stored. Here water is there. And here upside till this water is contained in this glass. So what do you mean by free surface? This surface where two medium. Which two medium? One is air and one is air, this one, and second is water, in which two medium are going to separate from each other, because here in this layer upside air is there and downside water is there. So this medium is known as free surface. What do you mean by free surface? The medium which is going to separate, or the layer which is going to separate the two medias, that is known as free surface. And as you can see from diagram also, that liquid is having only one free surface. From here only this air and water is going to separate from each other. Next we are having gases. So, what are gases? The molecules in a gases are far apart, or intermolecular space is much larger than liquids. So here, as you can see from diagram also, the molecules in the gases are very far apart from each other, or the intermolecular spaces. What do you mean by intermolecular spaces? The space between the two molecules is very much large as compared to liquids. Second point we are having, the intermolecular force are extremely weak and almost zero. As you can see, molecules are very away from each other. When molecules are very away from each other means intermolecular space is large. With large intermolecular space, intermolecular forces are extremely weak, or you can say almost zero. Okay. Next we are having third point. In gas, each molecule have independently move independently, and therefore gas is neither a definite shape nor a definite volume. As you can see, the gas molecules are moving independently here and there. Due to this reason, the gas is not having any kind of definite shape, plus gas is not having definite volume also. If I am going to contain the volume in this vessel or the gas in this vessel, here the volume are different, but same amount of gas is going to occupy this volume also, same amount of gas is occupied this volume also. So volume of the gas is not definite as we are changing the shape of the container. It can be stored in a closed vessel only. If you want to store gas, so you have to store it only in a closed vessel. For example, in a case of perfume or deodorant bottles, in perfume, one bottle is there in which gas is filled under a specific pressure. So that is an example where we are going to store the gases. Next we are having fourth point, a gas can be compressed easily. So, gas molecules, as we know, gas molecules are away from each other, intermolecular spaces are large, and force of attraction between the gases is least. So, we can compress the gases very easily by applying some kind of pressure. Okay. Next point we are having, a gas can flow easily. As we know, here for example, smoke is there. So, these particles are moving freely. Moreover, a gas has no free surface of its own, and gas do not have any kind of free surface. Means in a particles of gas, no two media are going to separate, because here all gases particles are there. If all gases particles are there means no different mediums are there. If no medium different are there means no separation is there, means gases are not having any kind of free surface. Next, we are having energy of molecules in three states of matter. So, how energy of molecules are going to change or vary from state to state, that we are going to study now. So first we are having in a case of solids. In solid state, intermolecular spaces are extremely small. As we know, here particles are very close to each other. If particles are very close means intermolecular space is very less. If intermolecular space is very less means force of attraction between the particle is very much large. The molecules are closely packed. Therefore, molecules cannot have translatory or rotational motion. Due to this reason, that force of attraction between the particle is too much high and intermolecular space is extremely small, particles cannot have translatory motion. What do you mean by translatory motion? That particles are not going to move somewhere. They are not going to move in a straight line. Plus, they are not having rotational motion also. Plus, they cannot rotate also about their fixed position. So the molecules can only vibrate to and fro. Here you can see also in this diagram that molecules are only vibrating to and fro. What do you mean by to and fro? Like this they are vibrating, or like this they are vibrating. So this is to and fro motion. So in solid particles are not going to show any translatory motion. They are not going to show any rotational motion. But yes, they are going to show the vibrational motion, or you can say to and fro motion about their mean position. Means they are not going to move from their position, about their position only they are going to move to and fro. So energy of movement of molecule in solid state is minimum. So here molecules are not moving here and there, due to which the energy of movement, that movement in the molecule, is almost negligible or minimum, you can say. Next we are having, at low temperature the amplitude of vibration of molecule is small. If we are having, for example, any kind of solid, and I am not giving any kind of temperature to the solid also, means this, like, solid is at room temperature only. Due to this room temperature, the amplitude of vibration, means they are vibrating simply about their mean position, not like too much fast they are vibrating, they are just vibrating, means slowly about their mean position. But as solid is heated, when we are going to heat the solid, what happens? When we are going to heat the solid, the vibrational amplitude, the amplitude of vibration motion in solids are going to increase. So with the increase in vibrational motion, kinetic energy of the molecules also increases. What do you mean by kinetic energy? Kinetic energy means movement of molecules are going to increase. So, a certain temperature called melting point, the kinetic energy becomes sufficient to overcome the intermolecular force. When we are giving more and more temperature, more and more heat to these particles of solid, they can vibrate more and more, they are vibrating about their mean position. And one certain temperature will come, one certain temperature they will gain, and that temperature is known as melting point, when this solid start converting into a liquid by removing the intermolecular forces among them. So this is known as melting point, and this process in which solid is going to convert into a liquid, this process is known as melting. Means here in this case, solid is going to convert into a liquid by heating it. Okay, and the fixed temperature that we are giving to this solid, so that it is going to break all the forces among itself, it is going to break all the forces and going to convert into liquid state, that certain temperature or fixed temperature is known as melting point. Next we are having molecular motion in a case of liquids. So in liquid state, intermolecular spaces are more as compared to solids. As we have learnt already that intermolecular spaces in liquid is more. Here distance between the particles are more as compared to solids, and thus intermolecular forces are also weak because particles are having little bit space between them. Due to this little bit space, their force of attraction is also quite weak. As a result, so molecules in a liquid can move freely here and there in the liquid. But one thing is there, if they are moving freely in the container, they are not going to leave their free surface, they are not going to come out of their free surface. Energy is there, kinetic energy is there, movement is there, but not that much movement is there that particles are going to come out from the beaker. Thus, kinetic energy of movement of molecules in liquid is greater as compared to solids. And as you can see that particles can move freely here and there in liquids. So, kinetic energy in the liquid is more, or you can say movement of molecules is more in liquid as compared to solids. Next we are having, as a liquid is heated. Now we are going to heat this liquid. The kinetic energy of molecules goes on increasing. It's not about only solids or liquids. Whatever thing we are going to heat, due to the heating, the particles are going to gain kinetic energy. Particles are going to move randomly here and there. And when we are going to heat the liquid, when we are giving certain temperature to that liquid, where the energy of the molecule is that much sufficient that they are going to move apart from each other, or they are going to overcome their force of attraction between them, that process is known as boiling. What do you mean by boiling? When you are going to heat the liquid, and by heating the liquid, the force of attraction between the particles are going to become weak and weak. Due to this weakest force of attraction between the particles, liquid then convert into a gaseous state, and the fixed temperature at which this process is going to start is known as boiling point. Next we are having in a case of gases. So in a gaseous state, the intermolecular spaces are very large. As you can see, the particles are very far away from each other. Particles are very far away from each other means the intermolecular space between the gases are very much large. If intermolecular space is large, in case of gases, intermolecular space is large, then intermolecular force is almost zero. Okay, thus gas can have independent translatory motion. So gas molecules, gas particles can independently move in all direction throughout the space. In whatever space we have kept the gas, in that particular space they are going to show the translatory motion. So kinetic energy, obviously kinetic energy in the particles or the molecules in the gases is maximum. They are going to move randomly here and there. Kinetic energy will be maximum as compared to solids and liquids. The translational kinetic energy of gases molecule increases on increasing the temperature of gas. And when I am going to heat the gas particles, obviously if it is a gas also, it is a liquid also, it is a solid also. Obviously by heating they are going to expand. Whatever thing we are going to heat, that thing, that matter is going to expand. Due to this expansion, kinetic energy of the gas molecules are going to increase. Next we are having next topic, change of state. So we can change the state of matter, like solid you can convert into liquid, liquid you can convert into gas, or reverse also you can do. Gas also you can convert in liquid, plus liquid also you can convert in gas. So what do you mean by change of state? Matter can exist in all three physical states. As we have learned already that matter is going to exist in all three physical states, that is solid, liquid and gas, under different conditions of temperature and pressure. But it is only possible under different conditions of temperature and pressure, because solid, arrangement of solid is different, arrangement of liquid is different, arrangement of gases is different. But yes, we can change the physical state of solid. We can easily change the physical of solid. How? By either heating it or by cooling it. So how it can be happen, we are going to study one by one. For example, ice solid can be converted into liquid. For example, you are having a cube of ice. So can you convert this cube of ice into water? Yes or no? Yes, obviously you can convert this ice cube in water by giving it heat to it. If we are going to keep this ice in a room temperature, or this ice is going to take up the heat from environment, it is going to convert into a liquid, that is a water. Again, water or liquid, when water or liquid you are going to heat further it is going to boil means it is going to change into the gaseous form. Similarly, on cooling, the steam is converted into water. Whatever steam is formed here, on cooling steam can convert into liquid. On further cooling, liquid can convert into the solid. Fine. So this is the process, this is a way by which we can change the state of matter. Here you can see dramatically that how state of matter can be changed. For example, first we are having a solid. So when we melt the solid, here firstly melting will come. When you melt the solid, it will convert into a liquid. And when you boil the liquid, or when evaporation takes place, it converts into the gaseous state. And when gaseous state, deposition is there, gaseous state directly converting into the solid state. So what do you mean by this freezing, melting, evaporation, condensation? All things we are going to discuss now. Change of state is a process of change of substance from one physical state to another physical state by changing its temperature. So here it comes the definition of change of state. That what is change of state? Change of state means when we are going to change the one physical state of substance to its another physical state by changing its temperature. This change of state can only takes place by changing its temperature. Either you can heat it, either you can cool it. Anything you can do. In that process only change of state can takes place. Okay. Next we are having change of state may takes place due to following processes. So what are the processes we are going to study here? How the change of state can be done. So first we are having the process in which a substance in solid state on heating changes to the liquid state. So first method we are having melting or fusion. What do you mean by melting? It is a process in which a solid state on heating, when you are going to heat this solid state, this ice you are going to heat, when this solid state by giving the heat going to convert into a liquid state, this process is known as melting. and the fixed temperature. And not at all temperature that ice is going to melt only, but yes, at fixed temperature this ice or the solid is going to melt into a liquid under atmospheric pressure. Means whatever atmospheric pressure is there in the surrounding, that should be same only, but we have to just change the temperature. So at the fixed temperature, when solid is going to convert into a liquid, that fixed or particular temperature is known as melting point. Next, we are having freezing or solidification. What do you mean by freezing? It is just opposite of the melting. As in a case of melting, we are that solid is going to melt into a liquid. But in a case of solidification or freezing, liquid is further going to change into the ice. So how you can convert water into ice? In your houses, how you are converting water into solid? How you are converting? By cooling it. So what do you mean by freezing or solidification? See the definition. The process in which a substance in liquid state on cooling changes to solid state. So that process in which we are converting this liquid state into a solid state by cooling it. As we know, when we are cooling the water into a freezer, then only it converts into a liquid or converts into a solid. And this process is only done at a fixed temperature. Means at fixed temperature only liquid is going to convert into a solid, and that fixed temperature is known as freezing point, and the full process is known as freezing or solidification. Fine. The heat released by the liquid during its solidification at its freezing point is known as latent heat. It is very important that what is latent heat of freezing. Freezing point, we have learned that freezing point means the fixed temperature at which that liquid is going to convert into solid, that is a freezing point, no doubt. But don't get confused in freezing point and latent heat of freezing. What do you mean by latent heat of freezing? For example, here I am having a liquid. So we have learned already this thing also, that whenever we are giving heat to something, that thing is going to expand. But when we are taking heat out of that body, that thing is going to contract. Similarly, in a case of liquid, when we are going to cool this liquid, cool means we are taking the heat out from the liquid. Heat out from liquid. Here we are taking heat out from the liquid, and whenever we are taking heat out from something, for example, this is a liquid. I'm going to show with a molecular arrangement. This is a particle arrangement of liquid. When we are going to cool the liquid, cooling means contraction is going to take place. So here contraction means particles are going to come close to each other. So this liquid is going to convert into a solid. But the heat that is going to release from this liquid during its solidification at a freezing point is known as latent heat of freezing. Whatever amount of heat is going to release out from the liquid by the cooling process, that amount of heat is known as latent heat of freezing. Next, we are having vaporization or boiling. So what do you mean by boiling? In boiling, the substance in a liquid state on heating changes into a vapor state. For example, in this vessel I am having a water. When you are going to heat the water, obviously water is going to boil. So when this water will boil, it will convert from a liquid state of matter to gaseous state of matter. But this also takes place at a fixed temperature. It means not at all temperature it is going to convert from liquid to gas. It is also boiling is also going to take place at a fixed temperature only, and that fixed temperature which we are giving to the liquid so that it can convert into the gaseous state, that fixed point is known as boiling point. And the process in which liquid changes to gaseous state, that process is known as vaporization or boiling. Fine. Next, we are having the heat supplied during the boiling process is known as latent heat of vaporization. So whatever heat we are supplying during the boiling process, so that this liquid can take the heat and convert into the gaseous state, that heat is known as latent heat of vaporization. Next, we are having condensation or liquefaction. So what do you mean by condensation or liquefaction? The process in which a substance in vapor state on cooling changes to liquid state at a fixed temperature. So see it very carefully, it is very wonderful process. So what is now going to happen? For example, here you are having bottle, and in this bottle cold water is there. Okay, a cool water is there inside this bottle. Might be you have also seen that when you kept this cold water bottle outside, like of the refrigerator, some kind of droplets are going to come outside this bottle. Why this droplets are coming outside of bottle, you know? Or your bottle is leaked? Or no, your bottle is not leaked, but what will happen now here? See carefully. In the atmosphere, as we know, moisture is there, water particles are there, or you can say moisture is there. When you will keep this freezing water bottle outside the freezer or outside the refrigerator, it will, all the molecules which are outside this bottle in the atmosphere, that molecules are going to stick to the bottle. So when they are going to stick, because in the atmosphere the molecules are not that much cold, in a summer the molecules are not that much cold, so when these hot molecules are going to come in a contact of cold bottle, they are going to become cool. So when they become cool, they are going to convert into the like droplet form. So this process, in which a substance in the vapor state, firstly these water droplets are in a vapor state, but when they are cooled, when they come in contact with the bottle, they converts into a liquid. So this vapors convert into a liquid. That is why we are watching different kind of or different like molecules of water outside the bottle. And this process, in which water vapor on cooling converts into a liquid, water vapor on cooling converts into a liquid, this process is known as condensation or liquefaction. And this also takes place at the fixed temperature. Okay, and this fixed temperature is known as liquefaction point or condensation point. And the amount of heat released during this process, how the heat released, as you know, in vapor, when the particles of water are in a vapor form in an atmosphere, here they are somewhat heat is there in these particles. So firstly they are going to release their heat out. When they will stick here, when they will stick on a cold bottle, they are going to release their heat out. When they will give out the heat, so they are going to convert into the liquid state. And this amount of heat released during this process is known as latent heat of liquefaction. Next, we are having sublimation. So what do you mean by sublimation? It is a process in which process of transformation of substance on heating directly from a solid state to the gaseous state. For example, in this vessel, you are having some kind of solid, and when these solid are going to take the heat from the surrounding, from solid they are directly converting into gaseous state. See these gaseous states. So this process is known as sublimation, in which solid directly convert into a gaseous state without undergoing into the liquid state. This process is known as sublimation. For example, naphthalene balls. Might be you have seen the naphthalene balls which we are keeping inside the woolen cloths so that it is not going to damage by the insects. So that naphthalene balls are also example of sublimation. That balls are going to take the heat from surrounding, and by taking the heat from surrounding, they are going to convert directly from solid to the vapor form. Next, we are having definition of sublimate and sublime. So what do you mean by sublimate? A solid which undergoes sublimation, the solid which is kept inside or this solid naphthalene ball, that solid which is going to undergo sublimation, that solid is a sublimate, and the gaseous form of that sublimate is a sublime. Okay. During sublimation process, the sublimate solid absorb heat which is known as latent heat of sublimation. As I already told, whenever sublimate is there or whenever any naphthalene ball or like anything is there, firstly that naphthalene ball is going to take the heat from the surrounding. By taking heat from surrounding, then only it converts into the gaseous state. So this much amount of heat that is taking from the environment, that heat is known as latent heat of sublimation. Or that much amount of heat that any solid is going to absorb, that much amount of heat is known as latent heat of sublimation. Next, we are having deposition or desublimation. Deposition or desublimation is the reverse of sublimation. As in sublimation, solid directly converts into the gaseous form. Okay, but in desublimation, gaseous form is going to convert directly into the solid form without undergoing into liquid form. So deposition is a reverse process of sublimation. It is also known as desublimation process. Deposition is a process of direct transition of substance. So what do you mean by this deposition? It is a direct transition or change of substance from gaseous or vapor state on cooling to the solid state. As in sublimation, firstly that solid is taking the heat from environment, then only converting into the liquid, or sorry, into the gaseous form. But here gaseous form will firstly going to cool. This gaseous firstly going to cool, then it will convert into the solid state without passing through the liquid state. So next topic we are having law of conservation of mass. So see carefully what is law of conservation of mass. In order to understand the law of conservation of mass, I am going to give you a very simple example. For example, in a beaker I am having a water. Okay, for example 5 gram of water is there in this beaker, and from outside I am going to add some salt in it. Okay, and the mass of salt in it is for example 1 gram. So mass of water is 5 gram, mass of salt is 1 gram. Here we are having water plus salt. Water plus salt. Here we will take the after means reaction. After the mixing, what I will get the salt water. So after adding water and salt, we get a salty water. Okay, here we are given with that water mass is 5 gram and salt gram is 1 gram, and after reaction or after mixing, when you will weigh the mass of this salty water, you will observe that this mass of salty water is 6 gram, which proves that the mass of the reactant is equals to mass of the product. Means whatever things we are taking before the reaction, before the mixing, that is known as reactants, and after mixing, which is the new thing we are getting, the new product which we are getting, that is known as product. So this is a product and this is a reactant. So you can see carefully in this reaction that mass of reactant, that is 5 gram plus 1 gram, that is 6 gram. Mass of reactant is equals to mass of product. So this is only the law of conservation of mass, which states that the total mass of the reactant is equals to total mass of the product. Okay, for example, here I am having a reaction which states that A plus B give rise to C plus D. Before chemical reaction, I am having the product A and B. For example, the mass of the A is MA and mass of B is MB. Okay. After reaction, mass of C is MC and mass of D is MD. According to law of conservation of mass, it is given that total mass of reactant. What is the total mass of reactant? It is MA plus MB. Mass of reactant A plus mass of reactant B is equals to mass of product C plus mass of product D. This is a law of conservation of mass which states that total mass on the reactant side is equals to total mass on the product side. Second definition for the law of conservation of mass we are having, that mass can neither be created nor be destroyed. Means we cannot create mass by our own, we cannot destroy any mass by our own. So mass can neither be created nor be destroyed. Okay, so this law is known as law of indestructibility of matter. So now we are going to study about the activity based on law of conservation of mass. So see carefully what is there in this activity. In this activity we are going to use one conical flask. Okay, in the conical flask we will use two acids, we will use liquids. After mixing the liquid, we will see that the mass of the liquids before reaction and mass of the liquids after reaction will be same. Okay, so what you have to do, see carefully. First of all, you have to weigh sodium sulfate and you have to weigh barium chloride. Okay, before the reaction you have to weigh both these liquids and you have to write the mass here. Okay, and afterward what you have to do, you have to mix both the liquids. After mixing the liquid, we will weigh the solution and we will see that before the reaction and after the reaction, both the reactant and product mass will be same. Okay, so see carefully how mass will be same. Actually, before the reaction, sodium sulfate, first of all we will weigh the mass of sodium sulfate. So this formulas you have to learn, or this atomic mass you have to learn properly. Like 1 to 20 mass you can learn properly. Up to calcium you can learn the masses, but after the calcium element all the masses will be there in your book or in your question paper in the bracket form. Okay, so here we are having liquids like this. First of all, we are taking the barium chloride and we are going to mix it with sodium sulfate. Okay, so see carefully what is the mass of barium chloride and sodium sulfate. Mass of barium is 137, and after writing the mass of barium you have to write the plus. Okay, afterward you have to write the mass of chlorine, because here two chlorines are there, means Cl2 is there, so 2 multiply. Now mass of chlorine is 35.5. then we are having plus, this one plus like same only. Then we are having sodium mass is 23, because here we are having 2, so 2 multiply 23. Okay, then we are having plus, Then we are having sodium. Sodium mass is 32. Then again plus. Then because we are having 4 molecules or 4 atoms of oxygen, we will multiply 4 with. Now mass of oxygen is 16. 4 multiply 16. So you have to add all these things. So after addition all these things, you will get 350 gram of barium chloride plus sodium sulfate. Now we will see for the after reaction. So after reaction, what is formed? After reaction, like precipitates of barium sulfate is formed. When you will mix the sodium sulfate and barium chloride, after mixing the barium chloride and sodium sulfate, you will see that barium sulfate and sodium chloride will be formed. Okay, so now we will see the mass of the barium sulfate and sodium chloride. So see carefully, here we are having the barium. So barium mass is 137. Then we are having sodium. Sodium mass is 32. Then we are having O4. O4 matlab 4 multiply 16 plus Na mass is 23. Because after balancing here we get 2, so you have to write 2 here. Okay, 2, then start bracket. Sodium mass is 23 plus chlorine mass is 35.5. After solving this full equation, you will get 350 grams. So you will see that total mass of the reactant and total mass of the product is same. Means when you will weigh before the reaction of barium chloride and sodium sulfate, total mass of this reactant will be 350 gram, and after mixing both the solutions or after mixing both the liquids, whatever solution will be get, when you will weigh that solution, that weigh of solution is also 350 gram, which proves that total mass of the reactant is equals to total mass of the product. This is all about chapter number 1st, that is matter, of class 8 ICSE chemistry. If you like the explanation, please like it, share it and subscribe our YouTube channel. Thank you so much.